take this off for a second. So let me just start quickly talk about the exam structure. Okay, so the exam will be 22 marks. Okay, there will be two sections. One, as you normally have, one section for MCQ. Okay, 11 marks, and one section for essay questions. Okay, there are in terms of essay questions, they are very typical essay questions. There's no like, because we haven't done any math or anything, so there's no problem solving. Okay, for the MCQs, 11 marks, there will be 22 MCQs. Okay, half mark each. Everything is from the slide.
11 mark for MCQ each.
Half mark. 22 MCQs.
From slides.
Everything is from the slide. Okay, the questions. I don't think there's any. If you have done the quiz, you should understand the nature of the MCQs, right? And the essay questions are talking about nothing minor. It is always talking about something, a bigger topic, right? Something. So if there is not something like a part of a slide or anything, it is directly pointing towards. For example, we covered maybe something about data marts, right?
Mm-hmm.
So it is talking about those major parts, right? So it is topical based, analytics, descriptive, predictive, prescriptive, data marts, all those things, business factors, and whatever major things that we covered across the three chapters. So chapter 1, 2, 3, everything is included. There's no trick in it. You just have to make sure that you understand topic as a topic. There can be questions asked about, back it up with examples. So those examples are already on the slides. But the question is not about an example. It is about the topic where you can back it up with examples. Okay. So whenever we are talking about details, you don't need to memorize those details, but you need to know. Maybe we can ask, because there are some examples asked, so you need to know if we are talking about that particular topic, you should be able to respond to that. Okay, everybody understand that? So there will be 4 essay questions, 11 marks, and everything is very clearly provided. So for example, where we want you to talk about something specific, we are normally providing you with a table. Like we want to ask you about aspect number 1, 2, 3, so we provide you separate spaces for that. Okay, so there should not be any confusion in terms of what we are asking. So if the question is asking about something having some dimensions, so we gave you space for that, like first, second, third, right? So as I said again, there will be 2 sections in your midterm exams. One, 11 marks MCQs, 22 MCQs. If you have given the quiz 1 MCQ, the nature of questions will be like that. Okay, and please bring pencils, because we are supposed to be using those bubble sheets to fill the MCQs. Okay.
Mm-hmm.
Secondly, the essay questions. 4 essay questions. A lot of distribution of marks, meaning that within the questions we are clearly telling 1 mark for this, 2 marks for this.
A, B, C, D, like.
Yeah, it could be, but for each segment we try to make it as clear as possible. Okay, so whatever we would like to ask, we are trying to make it very, very, very clear in terms of where the marks are going, and we are trying to provide spaces of whatever we specifically want you to write. Okay, any question regarding that? Okay, so
And Doctor,
yes,
did you make a decision about what I ask? It's
we'll
more
talk,
important.
We'll talk at the end. We'll talk about that. Okay. So let me just start talking about something that will eventually relate to your projects as well. Okay. So how's your Excel work going? Not looked at it?
Pretty good, yeah.
The deadline is not far.
The deadline not for which is the when
I already told it is 19th.
19th.
You need to be more
Next
careful.
week?
Yes.
That's fine.
The assignment, Excel
I
assignment.
think it with the plate.
No, we finished the Excel assignment.
So have you submitted it as a group?
No, not. Yeah.
Make sure first the groups have been assigned, self-assigned. Like if a member is there with you, make sure all your members are assigned. Because if the member name is not there, the person will not get any score. Okay. Secondly, if you are done, on 19th I will grade the assignments. There will be no extension in the deadline. Okay. So because it's a very small assignment, so you all need to complete your assignment, not Excel and the Word file. Remember, you have to write a report on it, right?
Yeah.
So make sure you complete that. Okay, so the next project will be based on this specific topic, the project. Okay, I'm just going to start a little bit now, and after, because we just have one more class left, so the chapter will not be finished. So after coming back, we'll complete this chapter, and there will be just like Excel training sessions. There will be training sessions on a software called Orange. Okay, Orange Data Mining. It's a free software, but very powerful software. So it does not require you to buy it or anything. Free of charge, full capability. There's no restriction on its free version or anything. Okay, it's a very, very powerful software. So what we will do is, the concepts that we are going to talk about here. Okay, eventually you will have to pick one of those approaches, and you'll have to pick the data corresponding to it, and then you'll have to perform data mining on it. Okay, so the chapter is called what? Data mining. So before going there, we first need to understand what data mining is, right? You must be hearing about data mining, but do you really understand what data mining is? So at least for today, we really wanted to increase our understanding of what data mining is, right? So once we start improving our understanding of what data mining is, then inshallah we will be able to actually do data mining in Orange. Okay. By the way, the field is quite big. It takes not just a class, few classes. It takes even degrees, just to understand fully all details of data mining. But we are going to do it in a very efficient way. You still will be able to perform some of those tasks, but at a specialized level, there are those finer things that you need to take care of. So we'll not cover that. Okay, at a very professional level, you have to take care of some very, very fine, important considerations before you trust your results. What we will do is we'll learn how to do it, but our results will be a little less trustworthy. Let me put it this way. Okay, but you will still be usable in normal circumstances, maybe not in a very critical circumstances where the implication of your results may be like affecting a country, right? But for a smaller company, your results will be fine. You can still use them. Okay, you understand what I'm saying? But at a very big level where things are big, money is at stake or something, the validity of your results need to be ensured. That is part of higher level. Then you can learn that in your master's degree. Okay, so we will talk about this basically the objectives and benefits of data mining and some of its technology and so on, and how you actually perform data mining. So steps involved in something called data pre-processing. One of the tasks that we must do is that whenever you're using data-driven decision making or data mining is always data-driven. The outcome, as you can imagine, is always as good as your data. That's a simple rule. Everybody needs to make this very, very clear. So whenever you get the data, and I've been talking about it especially in the first chapter, You remember traffic accidents? I told you that there were some problems and what we were telling was wrong, right? So one of the major things that is part of data mining is always data pre-processing, which means that you have to ensure that before mining this data, your data is actually correct and of good quality. Okay, so we have talked about that in the earlier chapters. So make sure that part is already done before you actually do data mining. Then today we'll start talking about methods and algorithms, that are there. I'm going to skip the case here. Before we go to the details, why people are certainly finding it important to do data mining. It's something we have been discussing it, so I'll not spend too much time on it. It is simply because competition is getting higher and higher, and you simply need to do better, right? And because of that, you need to understand your business better, you need to understand your market better, so that you perform better than your competitors. That is one of the drivers. The quality of data these days are becoming higher and higher, meaning that not just quality but the amount of data is higher and higher. We have been talking about that, right? All previous chapters was about collecting and storing and preparing the data in the right way so that you can use, right? So because of availability of high quality data, now people are looking for data mining. Increase in data processing and storage capabilities is another reason for using data mining. Now I must tell you that whatever techniques that we are going to discuss in this course, in the decision support system course, these techniques are not new. Most of these techniques are there for last 30-40 years. But suddenly people have started using it simply because those techniques were computationally very heavy. So now you are beginning to have large amount of data, number one. Number two, your data processing capabilities have become very strong. You have strong computers, powerful computers to deal with. Okay, and because of that, you are able to do data mining. I can even show you a small example that we are working with a master's student here. So I was just running a code that she sent me, so I can show you one real example of what we mean by large data sets and everything. Okay, so let's just first understand what mining is. Do you have any idea what data mining is, what it is used for? Yes.
Forecasting.
Analyzing the raw material to identify a pattern or something useful.
You have used a very, very important keyword here. So I'll come to that. Anybody else? Yes?
Forecasting.
Forecasting, okay. Trends. You are pointing towards that. Okay, so first of all, data mining is a non-trivial process, meaning that it's not a simple task. Meaning that you have to apply some challenging mathematical or artificial intelligence based approaches. Okay, so first of all, it is non-trivial. Non-trivial meaning that you're not just plotting a graph and looking at it. So it is certainly more involved than that. Okay, but the real aim, as some of you mentioned, is to identify valid. All keywords are important here, so I'm going to speak slow. Valid means true. Actually, they are there, which means that your data may even mislead you by giving you false information. Okay, that is why we are highlighting this word here called valid. Novel meaning something you're unable to see before, new, right? So something you're unable to see before, potentially useful. Even if I see something in my data that is of no use to me, that is not what we are looking for. We are looking for something in the data that is of use to me in my business. Okay, and ultimately understandable. You use the term patterns, right?
Yes.
And you use the term trend. Eventually, we are not looking for random things going on, because there are always two things in your data. There are always two things in your data. There is a pattern in your data, and then there is some randomness into your data. Okay? So have you seen a stock exchange curve? Maybe a temperature curve? Like in summer it goes like this. So when you see a curve like this, a summer from here till August, the temperature going like this, what do you suggest what is happening here? When I draw a graph like this, what do you see?
Increasing.
Goes up.
So your mind has picked not those random ups and downs. Your mind has picked up actually the pattern, the trend, because there is a systematic part of your data, right? But there is something, it is mixed up with something random, meaning that you cannot explain. So what is random? Random is something you cannot explain. Patterns are something that are systematic and something you can explain. So in data mining, we are looking for, when we say patterns and trends, we are referring to that part of the data that is explainable. You understand that? And many times there are patterns and trends hidden in the data that are mixed up so much with your randomness that just by looking at it, you are unable to see that pattern. You understand that? So data mining is all about finding those, not just patterns, but especially hidden patterns that are very important for you to know. Do you understand now this fundamental concept about mining? Mining is all about finding patterns, trends within your data that especially you are unable to see. Okay, that is one thing. So what is the keyword? Process. A process has to be used to what? To find those patterns. Okay? Non-trivial mean normally it's not simple. You know, you're looking for something more than what is just apparent in front of your eyes. Okay? Valid means some of the patterns may be misleading, so you just have to validate it whether what that pattern really means and whether it is actually true or not. Okay? Novel means, as I told you, the keyword novel means something new that you are unable to see, right? Potentially useful, and this part is very important. Many times people misuse the results because the algorithm suggests a pattern, but you cannot explain that pattern. It has to be understandable. It has to be explainable. Okay? So, data mining, you know, it's from the word mining, right? You have to dig deep into the earth. And the name, it's a misnomer, some people say, but the idea is digging deep takes effort, right? When you go dig into the earth, looking for oil or for coal or for minerals, you have to dig deep to find what is going on. You know, in your, you know, many things are hidden under your earth, right? So you're looking for that. So the word has come from there. So other names for it, which will help you understand its purpose, is knowledge extraction. The keyword here is knowledge. You want to extract knowledge from your data. Pattern, you already said, right? Knowledge discovery, finding something new. Information harvesting, pattern searching, data dredging. So these are all the terms people use for data mining. Okay. Now, how do we find those patterns? That is a big question for you to know. Data mining is not one technique. It is a collection of so many things that you need to put together. Okay. This part we have been discussing in previous chapters. Why is this part important? Because your data mining is data driven. You need to have good, well prepared data before you actually can apply data mining. So that part is already understood. So that is already part of data mining, right? Management information systems, databases, data marts, data warehouses, whatever we are doing is to, all our efforts was to get our data that we would like to mine. But on top of it, there are two major things. One, you need to have a set of tools that fall under a subject called statistics. Okay, then there is another subject, another set of tools that fall under what you call artificial intelligence, AI. I think you may have taken a statistics course, right?
Yes.
So, did you cover linear regression there?
Yes. The regression line.
Regression meaning that you have x and y, and then you have an equation, you find the intercept and the coefficient, right? That is like the simplest form of finding the relationship between input and the output, right? Y equals to mx plus c. So you find m and c while doing regression, okay? So that is like the earliest, the simplest kind of data mining. You're trying to capture pattern. What was the pattern? If I fit the temperature data with the days, that's like, you're trying to fit the pattern, right? Again, it was a pattern, but very simple one. But more advanced situations, you need what you call artificial intelligence. The level of our course is low, so we are not going into too much technical details, but I'll still give you few keywords, few hints of when we use this, when we use that. Okay? This is theory driven, this is computationally driven. So this is more explainable, this is less explainable in terms of what is under the hood of a car. So by design, which one you feel should be more better? The one which is more explainable or which is less explainable? Which is more explainable. But the one which is more explainable can handle only simple things. Okay? There's something called linearity in the data. Meaning that if the relationship between two things are simple, I'll not explain what linearity and non-linearity means, but something that is more simpler in terms of relationship, right? Statistics can only handle most of the times only linear relationships. For example, the regression that you learned is actually called not regression but linear regression, right? It is because of the fact that the relationship, they are making an assumption before even using regression that the relationship is linear. So the model fitting is based on the assumption that the relationship between x and y is linear. But we are not that lucky. Majority of the data that we face in real businesses is actually what you call non-linear, and then there's another term called non-stationary, meaning that we are facing not, stats won't work very well. Okay? So you understand the basis of how we pick things up. If we can make use of statistics, we prefer statistics because it is more explainable. We have a mathematical model to see and explain, right? But in many cases, statistics fail. Why? Because it simply cannot handle that amount of challenge and complexity and non-linearity. So what is the solution? The solution and the trade-off is go for something more powerful but maybe less explainable. Okay? And by the way, there is a third kind of an artificial intelligence building up these days. A lot of researchers are working on it, and it's not shown in the book. Even many people are not even aware of the name, and they call it EAI, explainable AI. And a lot of work has been, scientists are working on trying to develop techniques. The current techniques are not very explainable, but the one that they're trying to develop is trying to address this issue of explainability within AI. Okay, and they call it explainable AI. I'm talking about something, right, what is going on these days at the cutting edge research. Okay, so explainable AI. Okay. Eventually, this is backed by mathematical models, and that is why I say they are more explainable, because you can see the slope and the intercept, and you can explain it more. And this is backed by what is called machine learning. What is machine learning? We'll get to know more about that. Okay, but the eventual aim is the keyword, the most commonly used word is pattern recognition. You're trying to recognize patterns in the data. Okay, now here I want you to very quickly broaden up your mind, and I'm going to talk about that. When I say data, what does that mean? Okay, so I'm going to come to that in a bit. But when we think of data, we are generally thinking about numbers and graphs and so on. So data mining can handle far more complicated situations, so I'll talk about that. Okay, so sources of data or data mining is often a consolidated data warehouse, meaning that usually you need to start with the data, and where is your source? The source in businesses are normally the data warehouse or data marts. The environment in which you are working, it's just referring to you need to find the right software to use data mining. It can be client server, it can be web based. That is not a big problem. What is more important here is I want you to talk about this, because data is the most critical aspect of data mining. So what does data mean to you? We need to be what kind of data are we looking for? Are we just looking for temperature data against days, or what kind of data you think data mining can handle? Is it just numbers?
Everything.
Say again.
Everything.
Like?
names.
This is where I want you to open up your mind. It can be text, it can be numbers, it can be images, it can be videos.
How is that?
Yeah?
How it can handle photos and videos?
It is handling that. But this is the first step I want you to take. Okay? Text, and so it's not just numbers anymore. Okay? I'm going to even show you one quick example of what does a typical text data looks like. Okay? A real example of one of our masters, 3 of our master students are working on that. Okay? So I can show you exactly what data mining they are applying. Okay? But this first step is very clear. Data is not just numbers. Data is not just numbers. It can be a lot of text, categories, classes, ideas, images, pictures, tweets, Facebook posts, like even space images, anything. Right? Is that clear to you? So data is much bigger concept to us in data mining than just like an Excel file containing some numbers. Right? So is that clear? So, and of course the miner is usually the person who is doing the mining. So this is one of a very important task. When you're mining patterns into the data, your role is more challenging, which means that it is kind of two-way, meaning that some of those techniques to certain extents are dependent on you as well. Meaning that they are not truly like in Excel, in regression, you just put the data, click the button and you get like slope and intercept, khalas, I am done. Sometimes your role as an analyst is also part of the process. Meaning what? Sometimes, as I'm going to show you on the next slide, there's something called unsupervised learning, in which the data mining technique will tell you that I'm seeing something. You understand what I'm saying? The data will tell you that I'm seeing something, 2 patterns. But what are those patterns? What do you call those patterns? How do you identify those patterns can be your job. And we call them labeling in data mining. You understand what I'm saying? So your role can be more important. So for example, if I see a group of customers and I ask my data mining to see is there any, actually all of them are same, or is there any groups in my customer base? My algorithm will tell me I can see maybe 2 groups, but the clustering will not tell me what those group means. They say, look, I see that these 5 people seems like a group. They seem to have something common in them, and these have to have something common in them. And then you have to look at their characteristics and then label them, saying that, oh, it's like these are like maybe like regular high-end buyers. They look for expensive items. Maybe the other ones always look for discounts. You understand what I am saying?
Yes.
So your role is important, and for that you need to have creative thinking. Sometimes you need to. That is why I say it's a non-trivial task, meaning that your role is not just to click buttons. Your role is actually far more than that when it comes to data mining, right? So it requires a lot of thinking, a lot of analysis, a lot of evaluating the data, a lot of evaluating what algorithm is giving you back. Sometimes you have to tell, no, algorithm, you're not giving me right, so you have to change few parameters, what we call parameters, and ask it to please run it again, and the output might change, right? So it is a challenging task. Data mining tools, capabilities, and ease of use are another important things. So what is the tool that we have selected for this course? Orange, right? And it's basically behind it. It is a Python-based software, meaning that it is written in Python. And if you become even advanced user of Orange, we will not be doing any programming in Orange. I can show you how Orange looks like, but you can even add Python code to it if you need, at a very advanced levels. Okay, so I'm going to show it to you. So in that sense, we need to know not just that we need to have good data, but what kind of data we have to deal with in order to pick the right data mining technique for ourselves. Okay, so for example, the data can be categorical, numerical, but there's a third one missing here, which is text. There's another one you can add, which is like images. The other one you can add like videos and many other things, right? But within numerical data, there are at least 2 kinds of data that you might be facing. One is called the nominal data, and the other one is called the ordinal data. You may be aware of these terms. The nominal data, when you look at categories, those categories are in no order. The order is not important. Not random, but when I say good, very good, excellent, there is an order into it.
Okay.
Do you understand that? But when I say football team colors, red, green, brown, yellow, does it matter if I say red, green, brown, yellow, or brown, yellow, green? The order is not important, right? So the nominal data is the data where the order is not important, but in the ordinal data, the word from the word order is where some sort of ranking is there, and that is important. Okay, and then in the numerical data, there's something called interval and ratio data. They both look like number, but you have to ask one question to differentiate between the two. Is there a true zero in the data? True zero meaning that physically it means 0 means 0. For example, 0 degree temperature. What does that 0 mean?
It's an amount.
Set by someone. So for example, right now if it is 0 degrees, somebody called it 0 degree.
It's not true zero.
It's not a true 0. I called it 0. Why? Because when it's 0 degrees Celsius, how much is in Fahrenheit?
200 something.
Oh no, we are going to die.
700.
No, Fahrenheit.
Yeah, I know.
Fahrenheit, 32 degree Fahrenheit, not 200. Yeah. So you understand what I'm saying? In Fahrenheit, another scale, the same temperature, I'm giving it another number, right? But what about height? 0 height means 0 height. Can we call 0 another thing? What about weight? 0 means 0. right?
Zero mean
It
nothing.
represents nothing, right? But the temperature. So the one where you have arbitrarily set 0 for something, normally when you have 0, you don't have negatives. You cannot have negative weight, you cannot have negative height, right? But can you have negative temperatures?
Yes.
So those are interval scales. The one with true 0,
Ratio.
they are called ratios. Okay, ratio scales. So why we do need to know that? Because later, based on the type of the data, you will pick the right technique. Regression. If you're just doing regression with this, you use linear regression. But if you're using regression with these, maybe you have to pick another kind of a regression called logistic regression. Right? You understand why we need to know the type of the data? Because the type of the data will drive the choice of your technique. Right? That is why we need to understand the data. Now let's just talk about a little bit more about what do we mean by patterns. We still haven't talked too much about patterns, but pattern means what? Right? We said pattern, something in the data, right? So we need to know a little bit more about patterns. So data mining is supposed to be extracting patterns from the data, but we need to tell more about it. What does pattern means? Okay, so it is a relationship within the data. So we understand that already, that pattern has to have some relationship, right? Something that you can explain. So we will say that there will be at least, we can identify 1, 2, 3, 4 kinds of patterns that we might be looking for. Okay. Now this is where we will differentiate upon business problem. So my business problem can be to do prediction, or it might be I'm looking for association, or I might be looking for clustering, or I might be looking for sequential relationships. Okay, so now the question is no more like I need to look for patterns. Now you need to be, next stage is you need to clearly tell what kind of patterns are you looking for. Okay, so what is association? Association is when you're trying to relate things together. For example, I know that these two things go into this thing, so I can associate, like if I see a burger, you know, like a patty, I know that it goes into a burger. So I have like an association of that, you know, beef patty with a burger, right? That it always goes into a burger, right? We will talk more about all those things. So this is just to give you a very, you know, basic idea about what we are. So association is trying to create rules of relationship between items in our data. They can be relationship between items, so we'd like to find out. Again, we will talk more about that, so don't worry about that. Prediction is you to use the term forecast, right? So we are looking at clustering. Many times we have to group our data. That's called clustering. In MIS 502, half of the till midterm, all you learn is clustering. Okay, so we will talk about clustering, but the technical details, even we'll use, may do a project on clustering mining. But you know, when I said you're learning at a level where you're not too sure about the validity of the data, in that class you will have that theoretical knowledge. Okay, and after 502, you know that what you're talking about. Okay, but here we'll just learn how clustering is done, you know, in a software. Okay, clustering is about grouping. In marketing, did you hear about customer segmentation?
Yes.
Yes.
You can use clustering to do actually market segmentation. For example, I have all of you are my customers. How do I segment you? I can use
Gender.
actually.
Gender, age.
You're just telling me one thing. There can be so many things. Okay.
Yeah.
But I can identify clusters or group or segments within my thing using what? Using something called clustering. Sequencing or time series is something that is, you know, the temperature data and so on, you know, that is changing over time. So let's just try to learn few more things here. So we have made 3 groups: prediction, association, and clustering. here you will see two different things. What are the two different things that you're looking at? You have two words here, two keywords here: supervised, unsupervised. Okay. You first have to understand what supervised and unsupervised mean.
Supervised means someone who support you.
Not that. Okay. Unsupervised meaning that you're not giving any clues to the algorithm. You're just asking algorithm to find something. I'm giving you, a simpler view of things. Okay. I'm going to give you two examples, and I wish I would have brought that example here. Maybe I'll open the web. I'll go to Google and I'll show you that example. There are two techniques. One is called clustering, and then there is something called classification. Okay. In clustering, I'll just ask the algorithm to just look at all of them and find me if there are any groups. Did I give you any hint? Right? No. Now, I'll give you in classification. I'll give my algorithm something called labels. Labels meaning that I say dresses. Some of you are wearing top, right? And then some of you are wearing like pants and shirts. So classify them based on these two labels. Top versus like pants and shirts. Right? Can you see the difference between the two?
Yes.
One is guided. Guided by what? I told you, what to look for, right? But the previous one was nothing. So why do we use one over the other, and when do we use one over the other? Normally, when you wanted to do initial discovery, right, and you're not aware of what your data may contain, so what would be your choice? Unsupervised. Because you don't want to restrict your algorithm to think in a particular way. You want data to dig and find whatever it can from the data itself. That's called unsupervised learning. You're not guiding it. But if you're an expert and you wanted to guide the algorithm, then you're going to use supervised. Now let me see if I can find a very nice example of one over the other. Let's see if we can do that. So I'm going to use clustering versus classification. Let's see if I can find that very famous image. Okay, I can use this, but I was looking. Yeah, let's look at this example. Okay, let's do open image in a new tab. Oops. Where is my image? Oh, here. Okay. Can you see this picture up there?
Yes.
Now don't look at what is going on down there. Can you make certain groups? Can you see groups in this picture?
Yes.
What groups?
Bears and the one who walking for this.
You're trying to now cluster. I'm not supervising you. Right? You're using your own whatever mental sense algorithm to make those classes. Right? I see birds and four-legged animals and so on, right? So, but classification now I tell you, this is when I gave you labels. So I have to put labels on them, and I say, can you put them in right classes? Right? So this example is classification, and this example is clustering. Can you see the difference between the two? Right? Another example.
What is the difference?
One is, I'm guiding you to, I'm giving you the way to separate them.
Mm-hmm.
That's supervised. Okay? The other one, I'm not telling you, you are finding yourself a way to find the difference between them. Okay?
Mm-hmm.
So if you look at this one, when I draw a line, I say if it is in this side, call it class A. If it is like say height and weight, if I say height and weight, call them children. Above, call them adults. But when I remove this line, the problem happens when the data is like enclosed, where you don't know whether it goes here and here, right? And then clustering can and form. So you remember I told you that your job is very important. So normally what happens in data mining is clustering will give you these two circles. So that this is one group, this is another group. And then it gives it to you. And then it is you who has to analyze and do what is called label it. Right? So actually what happens in reality, you don't do classification, you actually do clustering first. You label them, and then next time when something comes, you say classified. You understand the actual way of doing data mining. So because I didn't know about this data, so actually what I did clustering, I analyzed it, I put them labels. What was the label I put based on height and weight? I call them children. Based on looking at their age and height and everything, I call them adults. And I say, okay, if someone is falling in this circle, it has to be, I'm going to be calling that adult. And the other one I'm going to be calling them children. And then this label next time I'm going to guide and I'm going to use classification. So if you understand this thing, so these are the two major parts. So some of those techniques are supervised and some of them are unsupervised. So what is the difference between the two? Labels. Labels meaning that you're using labels to guide the algorithm, right? So if I ask you regression, why are we calling it supervised? Because for every x we are labeling with a y. We are telling that for this x, this is the y. We are guiding the algorithm, right? For this input, the output is y. So y is the label here, right? Everybody understand that? Labels. So in data mining, under prediction, you see two techniques. Classification. Classification is when a new person comes in, I wanted to classify it into a class, and that's predicting, right? But we are calling it supervised. And by the way, classification can be done by a lot of different techniques. Orange can handle decision trees, support vector machines, artificial neural network, and many other techniques. We'll try to see, we'll see how many we can see in this course, okay? And then regression. Do you know linear regression? There's something called non-linear regression, regression trees, support vector machines, many techniques. So you first need to know, am I doing regression, am I doing classification? And once you know what you're doing, then you have to pick the right technique. How much time do we have left for the class?
Just 3 minutes.
5 minutes, okay. But then in association, what do you see? Unsupervised, right? It means that you're asking the algorithm to find relationships based on the data. Okay, clustering, what do you see?
Answer.
It is also unsupervised, meaning, but always remember, whenever you start data mining, normally you start with unsupervised, especially if it's a new problem, so that you understand the nature of the problem. But if you already understand the nature of the problem, you can go to supervised directly, right? But typically, especially if the problem is new, you go with the unsupervised one. Let me show you a data. Sorry, not this one. I don't want you to see. So it's a data that you are somewhat familiar with, and I'm going to ask you a few questions. Okay. So does this look familiar to some of you? Consumer cluster. Oh, it will take very long to run. But one of your in your Excel files, you may have seen this data about cheese, right? First of all, what kind of data just this column looks like? Numerical? Categorical.
Both.
This particular column.
Oh.
Categorical. Is it nominal or is it ordinal?
Nominal. Sorry.
Nominal, because the order is
Nothing.
not important, right? Same, right? But some of them are numerical, right? So we are dealing with this data, and the data set is extremely large, 30,000. You know, one of the things what we did, the results with the regression was giving us big problem. And the reason was that this data set was containing people with different genders, different ages, different incomes, causing regression to go crazy, because it just too many things to handle. So I'll give you an example of data mining. What we did was, actually we looking at just these three columns, we actually try to cluster these customers into groups. Why? Because some of the cheese are expensive, some of the cheese are less expensive, and we were seeing thing that maybe people with high income and high age were buying blue cheese, but not the ones with low income and low age, right? Those are like sophisticated cheese, not everybody buy, right? You understand what we are doing? So actually, what we did was we clustered the data into groups using k-mean clustering. Also, not k-mean clustering, something called hierarchical clustering. Let me just try to show you some of the things we were doing, so to give you an idea. So it's actually something real going on. Okay, so I'm going to show you something that it's a technical thing, but we were able to identify these groups in our data. Some of those 30,000, we call them bargain hunters. These are the people who are always looking for promotions. We separated them, right? And this, the lady who's working on it was trying to set, her work is actually to set the price of cheese such that your revenue is maximized. So we need to see how many bargain hunters are there, how many frequent customers are there, how many budget friendlies are there, how many luxury buyers are there, how many premium customers are there. And so we were able to find advanced career, middle age, adults, high price, and then we labeled it as premium customers. You understand how this is a real example going on. And I'm going to show you one more thing, which was the basis of actually this clustering. These are the groups we found using clustering. So this algorithm gave us, you actually see people here. So we analyze this group, we analyze this group, we analyze this group, this group, this group, this group, based on their age, income, categories, and so on. And looking at their attributes, we call them what I just showed you, bargain hunters and so on. Right? So then we will predict how many bargain hunters are there, how many premiums are there, and based on that we will set the price. There's a model that we are developing, optimization model. But can you see how data mining works?
Mm-hmm.
A real example, right? We started from the data. We were facing a problem because we have to set a price where we have so many different kinds of customers to deal with, right? We do not know how many premium customers are there, or bargain hunters there, or regular customers are there, right? So we extracted that, and now we will be, next time, what we are doing right now is trying to predict the demand for this, demand for this, demand for this, if we set a particular price, right? And then we will set a price that between them will give us the maximum thing. By the way, the regression code, it is a challenging task. So you can see things like that. So she's right now working on our prediction part, and we are still stuck into different things, but we are trying to handle it. But right now she wrote a code in Python, and we are trying to use a prediction model basically for a particular group.
Mhm.
But we are facing what is called categorical variables, so we'll see how technically we are able to do. Right? So I hope you get the idea of how data mining works.
Yes.
Right? So next thing what we will do is, the graph I showed you, this is at your level. You just put the Excel file into Orange, click, click, click. You say, I want you to do hierarchical mining on it. It will produce you these graphs. You go back and analyze the group and say, I'm going to label it this. So this might be a project for you, a project like this. Okay. The other one that I showed you, it's technically too complex. It's not at your level. So we are not going there, right? But I want you to at least during your project taste how actually mining works, at a simple level. Okay. So I will be giving you tasks like this. It can be another example, then I'll stop quickly, is where we had the data. I'm going to show you one more thing and then we will stop, because what does this data look like? What does this data look like? Just a second, you will see. What does this data look like?
Text.
A lot of
Text.
text. We were facing a situation where we were doing a literature review, something called literature review, okay? And it is a big field, so we didn't know what big topics are being discussed in all these papers. There are like 200 papers. So what we did data mining technique called topic modeling. There's something started off with something called word cloud analysis. You may have seen things like that on internet. Eventually we were able to perform analysis and we were able to find from data mining that all these papers are mainly discussing these 7 things.
Okay.
Demand forecasting, environmental sustainability, sea transportation, alternative fuels and so on. Right? You understand how it works. Text data. We were able to find that these 7 topics are mainly discussed during last 20 years in gas transportation research.
Okay.
Yes.
Can we, and I have something to discuss very quick.
Sure. I'm going to stop here and he has something